Hello, everybody. Welcome to Tuesday. It's my favorite day of the week. It's Hackster Café. We're talking to someone who's doing awesome stuff with hardware. And today's guest is Paloma Fautley, who is a robotics engineer and has a lot of interesting experiences that you've been through. I'm really curious to hear a lot about your journey, how you've gotten here. So, could you tell us a little bit about some of the places that you've worked and the projects that you've worked on? For example, well, I'll let you lead that.
Yeah, hi, I'm Paloma. I've been a roboticist for most of my career. I kind of like to say that I'm like a generalist roboticist. I've done everything from BattleBots to ocean robots, and my general tagline is that my job is being mean to robots because I either put them in a battle arena or throw them in the ocean.
So tell us about the BattleBot that you've been working on.
Yeah, so I'm part of the team Offbeat Robotics, and our BattleBot is Jinks. So I've been on the team for the last 2 seasons of filming, but it's a really amazing team started by my really good friends, Jen Herkenroder and Orion Beach, who have years and years of experience in both combat robots and just other experimental robotics. So it's a really awesome learning opportunity, and it's a cool project to be able to work on.
I love this. And what is the mechanism that this uses to fight other robots? I know there's a few classic shapes like wedges and hammers and stuff, and this is like a what do you got here?
Yeah, so this is a horizontal spinner. Hijinks is a gigantic horizontal spinner undercutter. So you can see that large bar there.
Ooh.
That is, I believe, AR 500 steel, so abrasion resistant and really, really hard. And so that is a bar that is somewhere around 70 pounds and spins with, I
Wow.
believe, like the limit of the top speed is 250 miles per hour at the edge. So I like don't quote me on this, but I think it's 1600 RPM. We calculated it out to be 41 kilojoules of force when that thing hits. So it's a pretty intense bar. It'll just obliterate your ankles. Um,
I will not.
so yeah, don't go near hijinks when she's spinning up. But I really, it's a cool design. Jen likes to say that we build the weird stuff. So it's a kind of interesting, odd design, and there's some really great unique benefits of having this design. You know, we have 3 points, so we can spin around pretty quickly with our two
Ah.
wheels, and the tail there is our third point of contact. So it allows us to put a decent amount of the weight down on that tail. So it acts as like the best wedge in the game, but also we can switch out
Mm.
different types based on who we're fighting. If we're doing another horizontal spinner or a vertical spinner, a flipper, a control bot, we can kind of switch out the different tails in the top armor to have a custom configuration based on who we're fighting. So it's a cool little robot. It can drive upside down. We call it
What?
helicopter mode. So
Oh my
if
gosh.
it's over, the bar's now a couple inches off the ground, and hijinks can ensue. So it's a cool robot to be a part of, and I've been really honored to be a part of that team.
I love it. So it looks like it was originally named Kestrel, and now you've got this sort of like vaporwave owl situation going on. Maybe not vaporwave, but like very sort of 80s revival with a little bit of low poly thrown in. I love this.
Totally. Yeah, all the designs there, the graphic design of that is Jen. Jen's an amazing graphic designer, and really kind of in collaboration with Orion came up with this like 80s Gem and the Holograms kind of
Oh,
vibe. And I love it. It's really fun. When I joined the team, one of my favorite things was like I need to come up with all these outfits to go along with this crazy vibe. So we're, I think, the coolest looking team on BattleBots, but it's a tough competition. There's some really cool
mm.
and we like to kind of hide behind how cute it is and be like, oh no, we're so cute, don't hit us. No, we're so gentle and simple and do anything to you. And then with that underestimation, we can get a few hits in.
Amazing. Yeah, you got two separate pages on here. Are these just from different years or?
I believe so. Yeah. So there's that one is from the year before I
Ah.
joined.
Oh,
So
you're on the team though.
I was only there for like a couple days during
Ah,
filming.
legit.
So I was part of the team, but I wasn't as big of a like a member of the team that year. And so I was only there for the tail end of filming, and they take these photos at the beginning.
Uh-huh.
Um, but yeah, it's an amazing group of people. I've learned so much from all of my awesome teammates. Just it's like a crash course in how to be like a rugged designer in a couple of weeks when you go on filming. It's really awesome.
I see what you did there with Crash Course. Yeah. Has the ankles thing ever been tested out? Have there been any incidents?
No, thank goodness. So
Ugh.
we really take safety very seriously. One of the most exciting and frustrating things about building a BattleBot is that most of the time you can't test it before you get to filming when you're in this weight class.
Oh,
So
wow.
the heavyweights is what they call them. They're 250 pounds. There's some caveats to that. Like I think you can go higher if you have a walking robot. But generally the max is 250 pounds. So these are pretty beefy and they can be quite dangerous. So we actually can't safely spin up a weapon bar outside of a battle box. So
Wow.
we have a safety disc that we put on at our shop. We'll put on this disc that has about the same moment of inertia, but is
Hmm.
a full circle, and we will use that to spin up to sort of check our electronics and our spin up, but we can't test actually hitting anything because it's just too dangerous. And even with the safety disc, if there's rocks on the ground or something like that, boom, now that's a bullet, that's a
Yeah.
projectile. So we have to be really careful with how we test things. And so we're like hiding behind stuff and kind of like peeking around, turning it on and hiding behind a shipping container or something to be able to make sure that we're keeping each other safe. Because these are pretty dangerous. Thankfully we have amazing people on the team that are just so safety conscious and have a lot of knowledge. So we haven't had any dangerous interactions, um, unless you're a watermelon, because we have at least once driven that robot into a watermelon. One of the perks of being a sponsor is that you might get the robot to come by and smash a watermelon for you.
That's amazing. So often on teams like this, you'll have people with different specializations. And is there any particular part of the robot building or design that you tend to focus on?
As a generalist, I kind of just jump in wherever I'm
Mm.
needed. The funny thing is, I believe I'm the only roboticist on the team, which is one of the best things. Is that every other person on the team has an interesting and diverse set of skills. So Jen, our team captain, is a welder who does all sorts of like amazing graphic design and also is an experimental aircraft developer and driver.
Wow.
Orion is an amazing machinist. There's like just so many cool people on the team who have different specialties. And I think one of my benefits is that I'll just jump in wherever. If we need to grind metal, I'm there. If we've got to paint, I think I painted every single face and hubcap because I just got
Wow.
into a groove. And so I would always joke that like my job was just I'm just here to paint stuff, like I do robotics all day. I'm just gonna hang out and paint things. And Jen would always joke back, like, you keep making those jokes and we're gonna make you actually, jump in and do something pretty intense. So I spent a lot of time working with like the motor controllers with Orion to kind of work on some issues we had with the speed controllers. I worked on building out drive pods. I've ground so much metal. So it's kind of one of those things where you just jump in wherever needs helping.
Yeah, so you mentioned doing a bunch of metal grinding on here, and I can't find it now, but there was a mention that the particular type of steel that you're using is particularly, you mentioned it's especially durable, especially hard, and I saw somewhere that it's like especially hard to machine, maybe because of that. Are there
Yeah.
specific ways that you handle that when you're machining I think is it AR 400 steel?
Yeah, sometimes we use AR 400, sometimes AR 500. That just has to do with like the level of abrasion resistance.
Ah,
And then we also use other materials, like sometimes we have titanium or aluminum. We play around with different materials for some of the different swappable components. We use, I believe the shaft is 17.4 pH, which is really good for making like a like our weapon stack needs to be really durable and hard, but it also needs to be smooth.
all right,
Um,
yeah.
if anybody's watching and wants to know more about the steel that we use, Jen put an amazing video on our YouTube channel that talks about all the different types of steel and why we use each type of steel in each application. But the biggest thing that we deal with is rust. So we are working out
Oh,
of Richmond, California, which is right next to the San Francisco Bay. And so we get tons of salty air, and we are always combating rust. And so we
yeah.
do a lot of grinding right before we weld to make sure that our
Oh.
our metal is really, really well prepared. We have to get off any mill scale, and we have to get off any like contaminants, because we want those welds to be really, really strong. Um, Welding with AR 500 is especially difficult. And so Jen does all of that because she's amazing. And so we have to make sure that everything is prepped perfectly for her, so that
Mm,
way she gets the strongest bond, and she gets the best sort of the best treatment of that metal. If you heat it up too much, you'll use some of the heat treating that comes with that raw material. So we
oh.
have to be really careful by not heating anything up too much, and by using specific types of welding to be able to get through what we need to. So Jen manages that pretty well by doing like tacking everything down and then filling in those welds on the seams. But the other thing that's really interesting is we have this bar we've been using for last 2 seasons, and we call it our extra stout bar, and it is shorter, but it also is thicker, and so it's like an inch and a half thick AR 500. And if you're looking at it from the profile, it's sort of trapezoidal shaped, and so we use those like tapered edges to be able to cut
Mm,
in. But because it's so thick, it has such heaviness behind it that it will really cut in. And so we can do hard,
wow.
like biting hits with that. The problem, though, is that to make this, we take this inch and a half thick AR 500 block, and we get it machined to cut out some of the weight in the center of it. So we scoop out some of the center, and then
Ah,
we
yeah.
get the paper on it. And I believe that takes 120 hours of machining. Um,
Wow.
so we are very thankful to our sponsors, who have really, really helped us out to be able to get those amazing machining jobs done, because we could not have done it if they didn't support us in that. But it is a technological marvel to have something like that created. And I remember some of the teams coming up looking at that and being like, I'm terrified of that bar. I don't want to use any other bar.
It's kind of the Claymore idea where it's, like, huge and heavy, and it doesn't have to be that sharp, like,
Mhm.
in theory, because it just, like, has so much force behind it.
Yeah, yeah, and sometimes we'll use, like, a combination of things. So we'll have the AR 500, but then put a little bit of, like, S7 on the edge to be able to have, like, something that
Wow.
can deform a little bit more. Like, there's just different materials you use at different places on a weapon to be able to just, like, really try to get the biggest, like, punch behind it. There's a whole bunch of like material science that goes behind this, because when you're working on this scale, you're hitting so hard. Nothing is really made to do this. Like, nothing commercially is made to be able to withstand these forces at this scale. Um, like, there's military things that are on a much bigger scale, and there's hobby things at a much smaller scale. But having something that's kind of in between the two here is really challenging to fit within that weight limit, but also have these intense forces. And so people are getting really creative with the ways that they solve these problems to be able to make sure that we're like hitting all of the, like, we're using our weight limit really effectively.
Oh, I have so many more questions. Okay, let's jump in with one of them. Jeeper one chimes in. Do you think your robot would be bulletproof theoretically? And it seems like a lot of this durability is focused in that bar, but you are fighting other robots. What kind of, yeah, protection do you have on it?
Yeah, so the 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 body is a monocoque frame, I believe is what it's called. And so we have it's all one piece that's welded together. And so the body is also made out of AR-500. So the body itself can take quite a hit. The thing about having a horizontal spinner is that when you hit somebody, you have to absorb half of that impact. If you're a horizontal spinner, and you're spinning up, when you hit somebody, boom, you can the force you're transferring goes into the floor. And so you're planting yourself down as you hit. But when you're a horizontal spinner, you're hitting yourself just as hard as you're hitting somebody else. And so you have to be able to withstand your own force. And so a lot of the challenge that comes with building the weird stuff is having these kind of intricacies. And so when we hit, we have to not only take that hit back, but also the torsional forces of that hit and have that distributed along the body of hijinks itself. So Orion and Jen have done this amazing job of designing the robot to be able to take those forces along that axis of the robot and be able to withstand that. We definitely don't withstand it sometimes, but every time we fail, we learn from that and we try to incorporate those lessons into improving the design. And that's what a lot of the videos on our channel are about, is about taking those lessons and sharing how we solved it and how we think we're going to get around it in the future so we don't have that failure mode again. And to get back to the actual question of do we think that it's bulletproof, I think it really depends on the bullet, but most of the time, yes. Bullets are incredibly high forces, but across a very small area. And so it depends on the armor and depends on the location, depends on the caliber of the bullet, but uh, these robots hit like bullets and we can take a few good hits. So I wouldn't be surprised if we can survive a bullet.
Dang. Well, I hope that answers your question, deeper one. Okay, so another question about this. We've talked a lot about the body of the robot. What's up with these wheels? Are these custom fabricated? Did you just like screw on pieces of tire onto a disc, or what's going on here?
Yeah, we have done a lot of work in understanding and designing these wheels. So there's a whole bunch of custom stuff going on here. So I believe that the wheels are made out of, oh man, what is it called? I can't remember the material, but it's the same material that's used in Huge's wheels. So it's a really, really strong plasticky material. And we drill holes in it at a specific pattern, and then we cut up small tires and custom bend them around because there's
Wow.
nothing that is exactly the right size that fits for this. So everything when you're doing BattleBots, pretty much everything has to be custom. So we custom cut tread and then we bolt it around. So even if part of the wheel rips off and part of the tread comes off, the rest of it is all bolted in. So we don't lose part of that. And then we've done a lot of work in designing the way that the wheel attaches to the body. So that way it can withstand a significant amount of hits. The video on our fight with Mammoth explains a lot about some upgrades we did to the wheels. And we've had definitely some lessons learned in how to build those custom wheels, but also how to make sure that they work. And if they fail gracefully. That's the biggest thing with BattleBots is like, if it's going to fail, make sure that as much of your movement and your weapon stays functional as possible.
Cool. And I'm pulling up these videos, by the way, of from the Offbeat Robotics channel, and y'all can find these links in the future in the description to the video. You can also just go look at the Offbeat Robotics YouTube channel after this, because there's lots more interesting stuff coming up. I have so many things to ask you. So, okay, pardon me. While I just show this for a second, you mentioned that there's like this kind of durability concerns at like the larger scale in the military and at the smaller scale in hobbyist robotics. What hobbyists are dealing with like this type of durability challenges and stuff like that, like forces?
Yeah. Well, I mean, combat robotics goes all the way down to, I think, 100 or 150 grams.
Oh,
So
sumo bots.
this, yeah, sumo bots and like, and your beetle weights and your ant weights.
What?
So you can build combat robots that are really, really small. And the forces don't scale linearly. So the kinds of solutions that will work on a 100-gram robot or on, a 3-pound robot are not going to be the same solutions that will work for a 250-pound robot. But you will learn a lot about how to build something, how to design something, and how to drive something by building a smaller scale and then working up. So anybody that wants to get into combat robotics, starting with one of those smaller weight class robots is a great way to get into it. And it's how both Jen and Orion got involved in combat robots. So really looking into something simple like that, it teaches you a lot about how to drive, how to build, how to fabricate, and then you can slowly scale up your new designs. One thing that we will do often is try out new designs on that 30-pound weight class or on the 3-pound weight class to really see, is this viable? And then scale it up for combat, for the heavyweight class for BattleBots. So it's
Wow.
really a process of trying things out on these different scales.
This beetle weight and ant weight thing is blowing my mind. I had no idea that existed.
They're
Uh,
so cool.
I also pulled up the monocoque robot frame slash general structural skin term. I hadn't heard of this before. This is really interesting. You were mentioning how that is the term for something where the entire chassis is sort of one big piece. That's really interesting.
Yeah, it's definitely one way of solving the problem. So having pieces that you can just take on and take off and put on is really great for modularity, which is very important in
Oh.
combat robotics. But having a single piece of a frame allows you to have strength in different places that you might not be able to have if you had these individual pieces. And so one of the big things that was happening in our fight with Malice is Bunny was saying, she has all of these exposed nuts on the bottom of Malice. And so if we hit the bottom of Malice with our horizontal spinner, we might shear those bolts and make it so that way, that could cause damage to the internals of that robot. And so we, as hijinks, don't have any real vulnerability underneath our robot. So when we get flipped over, we're oftentimes more dangerous because anything
Wow.
like a hammer saw or something can't really get into us in that position. And then we've got a big spinning blade that they would have to deal with. So there's a lot of complicated things that are a little bit different when you are looking at whether to go with a monocoque frame versus another type of structural system.
So why do you have the bar on the bottom?
Yeah, so it allows us to really keep our hits very low. It a lot of the beauty of hijinks is being able to stay underneath somebody else. So you've seen probably a lot of robots that are coming out now with wedges, with fingers, with something to get underneath the other robot to be able to flip them or to be able to hit them at their maybe more vulnerable spots. And so that's a big a big point is being able to control them, being able to get underneath them, because every robot is built to be able to be on the floor and driving. Not many robots are built to be on top of another robot. So if you can get underneath them, you have a different level of control. And when you have a blade that's spinning super, super fast, and you're underneath somebody, you can actually drop them on top of that blade, and it's like putting them into the blender. So our tail is like the best wedge in the game, and we can take quite a lot of hits with our tail and also get underneath other robots with it. So it's a brilliant design, and it allows us to use that low spinning blade to hit people where their wheels are, where their wedges are, and sometimes where their weapon is. So it's just one of the many options for a horizontal spinner. But you'll see people who have horizontal spinners that are more like drum spinners, like Malice, who are also incredibly effective and really, really pack a punch. They're just all different ways of doing things. And so Hijinks is just one of the super cool ways of being able to be a horizontal spinner.
Wow. Okay. I know that you've got so much else that you would do as well, and I don't want to like have this entire thing be about the BattleBot. Awesome as that is, but I do have a couple
Cool.
extra things to ask. So you mentioned that you've
Sure.
learned a lot from people on your team, and I'm curious what your favorite things are that you've learned from working with these cool people.
Yeah. I mean, so one of the maybe silliest things, but it just blew my mind, was from my teammate, Zach. And we were working on getting our motors to connect to the vesks. And if you've ever worked with motors or vesks, they both have problems. And they definitely both need to be replaced regularly. So the important thing with having motors like we use for our weapon is that they have phase wires. So they'll have 3 phase wires that all need to be the same length, and those
Mm.
allow the motor to spin. And the VESC, the electronic speed controller, will connect to that and tell them when to turn on and off. And so if they're different lengths, it can cause issues when you're trying to send controls. Now, this is like mostly pretty nitpicky, but it is important. And so when you're undoing and doing and undoing and doing these things over and over, if you solder them and you have to clip it every time to get
Oh
it
yeah.
connected, like if you crimp it and you have to clip it, you're changing the lengths of those wires. But if you're just soldering everything every time, that can be a lot of heat that you're dumping into a PCBA to be able to change out a motor or to change something out. And so Zach came up with this idea of half crimping, half soldering.
Wow.
So on one side, he would crimp on a butt splice, and then on the other side, he would just solder it. So we could just heat it up to pull it right off, but we could
Oh.
keep that strength of a crimp. And so it allowed us to do quick changes without changing the lengths of our motors from replacing a speed controller.
Nice. Oh, that's awesome. So, just for folks who aren't aware, a butt splice is one of these little shrinky guys. I think, isn't it? They sometimes have these like solder joins in the middle, and sometimes they don't, or do they always have that sort of solder join in the middle, or sometimes they're crimped, like you were saying?
Yeah, so sometimes they're crimped, sometimes you can solder things. Basically, it just allows you to take 2 wires and butt them up against each other. So there's a lot
Neat.
of different ways of doing that. And so the one we did was one of those that was like a long tube of metal. And so we crimped one side and soldered the other and left it uncrimped. So when we heated it
Oh,
up, we could
I
just
see
pull
what
it
you
right
mean.
out.
Oh, okay, yeah. I was thinking
Yeah.
about the two ends of the same wire.
Mhm.
Cool. Thanks for explaining that. And then
Yeah.
finally, we have a question from Ryan who says, "Are you allowed to use AI to maybe assist with robot control? This may be something that's happening more in the future."
Yeah, I think there's a lot of people playing around with the idea of using some sort of autonomy to be able to assist their battle bot. So I think you're probably not going to see fully autonomous robots competing with driven robots anytime soon, because there's just the human element changes so much and things move so quickly that I think it'll probably be a while before we see fully autonomous BattleBots that are competing against somebody who is making decisions in real time. But there have been a lot of people talking about doing autonomous robots against autonomous robots. I'm a big fan
Oh
of
yeah.
autonomous or semi-autonomous robots. And so having that autonomy built in is valuable. I don't believe many people are using it yet, because there's just so many variables that you would want to be able to control, and having something not quite work or make a decision you don't understand as the driver would be pretty challenging. But I could see that being something that somebody incorporates really successfully, depending on how they do it. But anytime you're using a computer making decisions and hardware, you know that there's going to be hijinks.
There is, you know, there's that whole question with AI ethics in general, where like if the robot can't be responsible for its decision, it shouldn't be like put in charge of anything that's really important. And you know, usually it's applied to things like, you know, if it's in charge of hiring and firing people, or if it's in charge of like arresting people or making, you know, identifying suspects and stuff, that it shouldn't be. If it can't be like, there's no one that can be accountable for those decisions, then it shouldn't be in charge of that. I hadn't even thought about like, what if it's like swinging around a 250-pound steel bar at ankle height or however heavy it was, and like someone gets hurt by that, like who?
Yeah, it's very similar to the questions around autonomous cars, is that like
Right,
you
of
can do a
course.
lot of damage if you're around people making these decisions. And so BattleBots take safety really seriously. And so there's a lot of things you have to do in putting your robot into the arena and taking your robot out of the arena, and adding some question marks in there can add a lot of safety concerns. So I would expect to see it happening more at the smaller scale. And then if that works really well, considering to move it up. But with the safety concerns, I don't know that we would see it at the 250-pound scale anytime soon. But it could be interesting. And you might see it on something like maybe not the main weapon or the drive, but maybe you would see it on a flamethrower, or you would see it on something trying to somebody's secondary weapon that's trying to add something on top of what they're already doing.
Right. Ah, wow. Okay, so thank you so much for telling us so much about your experience with BattleBots. I'm pretty sure there's more that I have got jotted down here. But okay, so you also do other really cool stuff though. There's ocean-going robots. So both Sofar Ocean and Sail Drone, which you've worked at, are ocean robots. This one is sort of like little smart buoys that sit around and are solar powered, and you toss them out and they kind of sit. Well, you can explain these better than me. Would you like to explain more about Sofar, and then also what Sail Drone is?
Yeah, so I've actually worked on 3 ocean robots now.
3!
So weirdest niche. Yeah, the first ocean robot I ever worked on was my first job out of college, and it was the Park Ocean of Things drifter. So
Ooh.
Xerox Park, if anybody's familiar, it's
Yeah.
now owned by SRI. And so we were a research company that did all sorts of fun and weird cutting edge research. And I was hired there as an intern to build the first prototype of this system. And Park is amazing. They like essentially, I believe, invented the GUI, the Ethernet, the computer mouse, like they like old Silicon Valley tech company. And so I was very, very honored to be brought on there to work on this project. And we were building a drifter that was working on being able to send and receive ocean data in real time. And so I built one of the first prototypes, went out, threw it in the ocean, and spent some time figuring out how everything was working and how to communicate. And it was an amazing team of people that worked together on that project. And we went from 1 to 1,500 in a year. And I
Wow.
learned so much about that project. And then while I was working there, I kept seeing people talking about these SOFAR buoys that were really similar, but very different. So they had totally different materials, totally different use case and customers, but very similar sort of experience, right? So it's all about taking ocean data. It's all about being able to understand the world's oceans. And I ended up switching over to SOFAR to be a mechatronics engineer there. And what the SOFAR buoys do is they float again at the top of the water, and they take data about the ocean. But the SOFAR buoys have this really interesting smart mooring system where you can take data down into the water column. So you can actually have sensors connected to the bottom of the buoy down to wherever your anchor is and take data at different heights in the water column. So they are using that combination of systems, either just the floating buoy or the buoy with that mooring, to be able to get
Is that this
really
thing here?
Yeah, that's the smart mooring there.
I
And
just showed it for a
so
second, but so cool.
yeah, it's really cool. And it's really well designed and helps solve some interesting problems around taking data underneath the surface. And so I worked there helping to work on that smart mooring to help understand its limitations and put some data behind when and how you should use that smart mooring. But they're using the platform for some really interesting applications around being able to have ships traverse the ocean more safely and effectively, and also understanding our climate. So things like being able to deploy them in a hurricane, you can then see what is happening as a hurricane passes over a buoy. So there's a ton of really cool stuff you can do with this platform, and I believe it's relatively low cost compared to other similar platforms. So it is a really great entry point for a lot of academic groups that want to be able to measure a specific place in either the ocean or lakes, rivers, things like that.
Cool. So for anyone who's listening along, the smart buoy that we're talking about is a sort of small yellow plastic, about the size of like a basketball with a little skirt on it. So I'm looking at it. And it's got on the
Good example. Yeah.
on the top, there's like a sort of plus sign of solar panels. Are there 4 or 5 on there?
I believe there's 5. It's been a little while, but yeah, it allows you to get solar, like if you go completely flat versus completely vertical with your solar panels, it can change how much sun you get at different times of year in different locations. So if you are at the equator, you want them flat. If you're near either pole, you want them higher up because the sun is going to be at a higher angle. So having something that's at an angle like that allows you to get the best of both worlds and be able to perform better at places with maybe less sun. So it's a really brilliant design.
Wow, yeah. Sorry, I'm taking a note here.
Totally.
Okay,
Yeah, and then the most recent ocean robot I worked on was Sail Drone, which is the classifications are very important on it. So it's an uncrewed ocean vehicle. So it's a vehicle. It's not a vessel because it doesn't have cargo, but it is essentially an autonomous sailboat that can sail all around the world, take data, send that data back in real time, and do really, really high value ocean research. So this can be ocean mapping, like ocean floor mapping. This could be things like, marine mammal detection or surveying of what fish are in a specific area. This could be climate and weather data, similar to what SOFAR did, but actually you can sail these into hurricanes. And these are the largest scale of ocean robot I've worked on. So the first 2 were somewhat around basketball sized, but this one here is anywhere between 10 and 20 meters long.
Wow.
So there are 3 sizes that are, sorry, 7 to 20 meters long. So there are 3 different sizes, and they have different like positives and negatives to each one, but they are a really, really high quality and just technologically astounding machine. I really enjoyed working on it.
Yeah. So this the sail drone vehicle is do you call it a UOV or do you not use
USV, I think, uncrewed
USV?
surface vehicle.
Surface vehicle. Uh-huh.
Mhm.
So yeah, this one, like you mentioned, is sort of the biggest, and also when you look at it, it's sort of like it's not gangly, but like comparatively, it's the gangliest.
Yeah,
And
it's
like
got a lot of parts that stick out.
it's like this orange sort of flat kayak looking thing with an interesting sort of sail on top that's shaped like a wedge with like a stick through it and another little rudder thingy on that. Is that
Mhm.
like for steering or what's going on there?
Yeah, so the wing design is actually a big part of Sail Drone's identity, and that
Oh,
has to do because the CEO actually got, I believe, a world record for fastest wind-powered vehicle
wow.
over land using a very similar wing design.
Huh.
So looking up Richard Jenkins, you can see his original uh, like wind-powered vehicle, and this sail drone uses a similar design to be able to really effectively move in the wind. So a big part about building these is we want them to be, we wanted them to be more environmentally friendly than other ways of gathering ocean data. So if you had a crew out there, it's a lot of fuel. You have to, bring food and tons of fuel, and it costs a ton of money to be out there every day taking data. And with this system, with the Explorers, which is the smallest version, they could be sent out just using solar power and wind power and be able to sail theoretically indefinitely just on those 2 power sources. So
Wow.
the designs really allow for efficient transversal of the ocean.
That's so cool. And when you look at it, it kind of looks like it almost looks like an airplane kind of stuck sideways onto the top of there, but that's the kind of idea. And I'll put the link to the Greenbird, I believe was the name of the land vehicle that you were talking about by Richard Jenkins, the CEO,
Yeah.
founder. And look at that, they found a little shipwreck. Sorry. It's very
Yeah, it's
cool.
so cool. And actually the one next to it, that underwater seamount,
Yeah.
they actually found that right before I joined, I believe, and they found an underwater seamount, so a mountain underneath the ocean surface that nobody knew about, that's taller than the Burj Khalifa,
What?
and it's off the coast of California, and just
What?
yeah, and so it was just undiscovered ocean floor topology, and that's why being able to do this deep ocean mapping is so important, is that we would never know about these features if we weren't out there mapping them to be able to better understand how the ocean moves. The ocean is so undiscovered and so unexplored, and being able to understand the topology under the ocean lets us better understand how water is going to move and how our weather works, and that allows us to do everything from being able to better predict weather, but also being able to better find people if they fall overboard, because we'll have better models of where the ocean's going to go. So
Wow, yeah.
there's a lot of really complicated stuff that you can do with ocean science, and it's a brilliantly interesting field.
The fact that it is, you can use that kind of thing for modeling the water flow reminds me so much of this, bay model that we have here in the Bay Area. Have you been here?
I haven't yet.
It's like
I need to
okay,
go.
it's a scale model of the entire Bay Area water system, including a bunch of the
Whoa.
watersheds and stuff, and it So they had to make some tweaks because apparently the bay is really, really shallow. So but they use it to model the way the water flows around it. And they've got all these little sensors and markers and little pumps and stuff. And they had to make it deeper than it really was proportionally. But they like compensated by putting little thingies in the water. And like, it's amazing. So you're basically able to do that sort of virtually for entire ocean systems, which is incredible.
It's
So
so
cool.
cool. And like the California coast is such a fascinating place to be studying ocean science because the like the ocean is so deep, so close to the coast. You know, if you're
Mm.
looking at satellite imagery of the East Coast, you see this long section of shallow ocean before you get to deep ocean. But on the California coast, it is so thin that we get to deep ocean so quickly. And actually, if you look into the Monterey Bay, you see that deep ocean goes even into the bay, and you get this really, really nutrient dense water that is being forced up into these bays, both into the Golden Gate in San Francisco, but also into Monterey. And it brings this super, super lush, nutrient dense water up. And that's why we get such interesting like ocean wildlife in these locations, because there's so much good food and there's so much like rich like ocean life in these areas. So if you haven't been to the Monterey Bay Aquarium, definitely go. It's a brilliant place to be if you're
Oh,
interested
yeah.
in the ocean.
Absolutely. Okay, so we're nearing the end of our time here, and we've gone through most of the actual questions that are in the chat, but I have a few lightning round questions I'd love to ask, and feel free to take these a
Sure.
little longer. We've got some time, but yeah.
Cool.
So when you're working on a robot, let's go with BattleBot for right now. But what's your favorite part to work on? It doesn't actually have to be a BattleBot. Any robot. What's your favorite part to work on? It's a huge question. Feel free to narrow it down.
It's such a huge question. I
I
think
know, I hate it.
I really appreciate taking a systems level view to a robot. So being able to understand it holistically.
Mm.
I always love a good deep dive, but being able to understand how all of the pieces work together is, I think, the part that brings me the most joy. So being able to have that system level integration, understanding how the hardware and the software play together, how the environment and the robot need to work together, and understanding the edge cases. Most of my work has been on
Mm.
autonomous or semi-autonomous robots. So outside of BattleBots, almost all of the robots I worked in have some level of autonomy. And so when you're working with autonomous systems, being able to understand every edge case and predict all of the ways that something can go wrong and then come up with elegant ways for that to fail is my
Mm.
favorite. I actually have several talks that I've given at places like North Bay Python where I've talked about failure, embracing failure, failure analysis, and learning from your failure. And so being able to understand something holistically, system level, embrace the failure that you see and learn from it and grow is the part that I think I have most embraced in my career and most enjoyed when I'm approaching a project. And those are all things that you can do for any project that you're working on is if you learn those skills about how to see the failures, learn from them, and predict them in the future, you can do that on any system.
Awesome. And you mentioned on your LinkedIn that you actually did a sort of whole hackathon around this concept at IEEE. Let me pull that
Yeah.
up. I
Yeah, I
love that
forgot
option.
about that.
The idea, just like
Yeah, I did a, pardon my French, shitty robot competition where it was a 12-hour robotics hackathon where we asked people to build a robot in 12 hours with an impossible task. And the whole point of that was to teach people to be okay with failure. So the first we did a couple like trial runs of it, but the first one that we did was the prompt was your computer is not secure. Build a robot to make your
Ooh.
computer secure. And so we had people who had never programmed in their life or worked with electronics showing up to this. We had people who are robotics majors showing up to this. And we had little workshops where we taught people, you know, how to work with some of the electronics. We had 3D printers and laser cutters and all sorts of like prototyping like stations available so people could build this. And the biggest thing is we wanted people to get out of their own heads and just build something. But with that prompt, we had everything from a robot that would beep out messages in binary to make your computer feel more secure, to robots that would try to like smash your fingers with a hammer if you put your password in wrong. Like, it was chaotic and beautiful and brilliant. And we had bingo cards, so every different type of failure you got a bingo stamp, and if you got a full like bingo, you could get all of these, like, you got merch and a bunch of like swag. So it was really about like understanding that failure is a part of the process, and like letting go of perfectionist tendencies and being able to understand that rapid iteration teaches you more than thinking over every single possible solution and trying to
Mm.
figure it out before you start. Like, just get started. Just get started with your project and learn and understand that getting good at something only happens by being kind of shitty at stuff for a while. So it's really important.
Yeah. Okay, so A, this event sounds amazing. And B, like, that's something I'm absolutely struggling with my robots here. I'm like trying to make like I've been trying to make a new version of Archimedes, the like owl one, for like a year now, and I keep like getting all stuck up in my head about it. And I think part of it is just like feeling time scarcity. So it's like I don't have time to iterate, but that's absolutely what I should be doing. And thank you for the inspiration. I'm curious
Yeah,
also.
just fuck it up. Make a bad one. Like, just make the worst one you can in 2 hours, you know? Like, just make the silly, shitty version and, like, get all your bad ideas out. Shake them out of your brain.
Pick the worst one you I'm writing this down. The worst one you can in 2 hours. Yes! I'm also curious if you've ever participated in this Hebocon concept, the,
I
like,
haven't yet, but I
wearable robot
love
computer.
HeboCon. Oh, I've seen it at maker fairs and I've always loved it. It was definitely a big inspiration when I was going to the Shitty Robot Hackathon. Um, and just being able to enjoy the silliness of building something dumb is something that I think is really, really important. Like, Simone Yetch is
Yeah.
such an inspiration for me. And she was also a huge part of why I wanted to do this at my university. Is I saw so many people struggling to just get started, and I saw her just building these things that are actually technologically brilliant and so challenging and so like, she had to learn so many interesting skills to be able to do the dumb things she did, but she didn't let it get in the way of her achieving something. And so for my first talk at North Bay Python, it was called How to Build a Terrible Robot. And I built a robot that would pat you on the back when your code failed. And so it would
No!
just say, there, and pat you on the back. And, you know, just building something that is silly and dumb and doesn't have any use lets you get out of your own way of standing in your way of achieving something really great. And that's something that I really try to, it's a lesson I had to learn. And so I made a competition to help me learn it for myself, and to help other people get a space to embrace it as well.
Okay, well, I'm definitely putting this in the links to the video. Everyone, of course, almost all of the things that we look at here on the screen today, I'm going to put in the links, so you'll be able to click through and go check those out. Oh, you know, for a lightning round, I don't care though. That was awesome. So I have one more question. It's the question, which is, what new or developing technology are you most excited about right now? Like things that you're excited to get your hands on in the future that might be a little out
Mm.
there that might help the world or yourself.
Yeah, I mean, I'm always a big fan of robots that make people's lives better
Mm.
and robots that help people.
Mm.
There's a lot of really cool ways that people are approaching that problem, but generally climate tech and being able to find green ways of using robots that make people's lives better, that make people happier and more productive and more efficient, but also just experience the world better. Anything that does that, I'm always excited about. And I think I'm, right now I'm in between jobs and really looking for what's next. And I'm really excited by anything that is like climate related, but also just helps improve people's day to day. That's the stuff that I find really cool and interesting and want to be a part of. But outside of technology, the stuff that I'm really excited about lately is just working with people. I love working with people and like seeing their ideas blossom and bloom. So for me, like my favorite project is whatever my friend's working on, and let's figure it out. Let's find a way through it. So it's it's super cool. I'm really inspired right now to do a lot of different things.
Yes. Well, I anyone who gets hold of you is going to be so lucky to have you on their team. This has been a delight. I feel like there's so much more I want to ask you, but you're just going to have to come on another time. I'm sorry, but like this is going to have to happen. when you get your next cool robot job, you got to come on and tell us about it.
I'll hit you up for sure.
Yes. Okay, everybody, I'm going to go back through the links that we looked at really quick. We're going to take a quick tour back through. I'm going to watch the heck out of this talk. That's the one Paloma was talking about with how to build a terrible robot. So we've got your LinkedIn, we've got hijinks on BattleBots twice. Actually, there's 2 different pages, but it sounds like this is the main one that you iteration you were on. There's the fandom page for hijinks on the BattleBots wiki. There is Sail Drone, there's So Far Ocean, and there's so much more we could dig into there. Oh, but it's fascinating. Go check those out. There's the Offbeat Robotics YouTube channel. Go subscribe to that. And then, of course, there's all these interesting concepts we talked about: monocoque robots, beetle weight and ant weight robots, which I had never heard of. Incredible different types of BattleBots. The Ocean of Things project, Xerox Park. I went there once actually for a make event. I think it was called like Makers of Hardware or something, long time ago. But anyway, yeah, definitely gonna watch this talk. Thank you everybody for joining us. It's been a delight having you in the chat, asking questions, sharing your own thoughts about, and like brains spitting out about what you're inspired to build. And thank you again, Paloma. This has just been a delight.
Thanks so much for having me. I've really had a great time and looking forward to whatever I can bring to you next time.
All right, cheers everybody. Hack on.